All right, so we're back and we are going to be doing 5.2 in the geometry chapters. And it says, do you see what I see? So your main goal for today is to look at what you see. Okay, look at what's in front of you. And there's some of you that are going to be like, no, I don't need to say that because that's really obvious to everybody. Actually, the most obvious things are the things that I'm going to want you to see today, because that's going to lead you to understanding like the next part. So today you'll be able to examine features of diagrams to determine the story of how the diagrams were built. Write a paragraph to prove a conjecture that surfaces when analyzing a diagram. So wait, Ms. Johnson, we're writing paragraphs in here? Kind of. So we're getting into this land called proofs. And what proofs are basically like writing a paper, except for you're doing math instead of like, whatever, analyzing the character and the plot and stuff like that. So what can I learn by analyzing the features of a geometric diagram? And what assumptions am I making when I interpret the features of a diagram? Okay, be very careful with assumptions, right? Some of the assumptions, like it looks like it, are not valid in math and geometry. So can I tell the story of a diagram? What features of the diagram were drawn first? Because everything else depends on its existence. And what features were drawn later? How can I write a concise description justifying something new that I noticed while analyzing a diagram? So we're really working on two big things here. Number one, we're going to be working on observing. And then number two, the thing we're going to be working on is like being able to prove something based on those observations. Okay. So let's get started. Okay, so that says, in the previous task, how do you know that? We saw the following diagram could be constructed by rotating a triangle about the midpoint of two of its sides. The final diagram suggests that the sum of the three angles of a triangle is 180. Do you remember us talking about this? Okay, this diagram tells a story because you saw how it was constructed through a sequence of steps. You may even have carried out some of those steps yourself. So remember, we had this one triangle, and then we tore off the corners and we put it together with the other sides, and then we were able to figure out that because this is 180, then the triangle's angles add up to 180. Sometimes we are asked to draw a conclusion from a diagram when we are given the last diagram in the sequence of steps. We may have to mentally reconstruct the steps that got us to this last diagram so that we can believe in the claim the diagram wants us to see. So can you guys tell me what you see here? What do you see here? What do you see? Very good. Yes, someone says, I see two circles. And I'm sure someone said, of course you see two circles. That's so obvious. Actually, no, I don't want you to like fall into that trap, right? Because the trap is, oh, that's so obvious. I don't need to say it. No, actually, that's really important because circles are used to tell us something. Circles are used to tell us something. And like, let's see if you understand what I'm saying in a second. So what else do you see? Someone said I see a triangle. Yeah, someone says it looks like a Venn diagram. Do you guys all know what a Venn diagram is? They use it like this, right? And then they say all the things that me and you have in common go in here. Here's all the things that you like, but I don't like. And here's all the things that I like, but you don't like. Very good. All right, what else do you see? There's more, by the way. So the answer is yes, there's more. And I want you to observe it. So someone's going to see this. That's what I have full confidence in. What else do you see? What do you guys see? Come on. You see something. I know you do. Someone says, The letters on the corners, very good. So we actually call these vertices. Everyone say vertex. Vertex. So a vertex is a corner of a triangle. Some people call them corners, but it's the point where two sides come together. So everyone say vertex, vertex, and a vertex makes three vertices. Very good. Someone noticed that they're capital letters. That's really actually important. Some of you are like, really, Michelle? Yeah, actually. So points are always going to be labeled as capital letters. So I won't ever be able to label this point with a lowercase letter a. That's just not what we do. Okay, this is not the way we do math. Lowercase letter a's mean something else. They represent other things. Okay, so someone said the circles have dotted lines and the triangle has a solid line. Very good. The circles are dotted lines and the triangle is a solid line. So usually dotted lines indicate that they were drawn after something else, or they were drawn as extra pieces to help you figure out something else. So very good. So again, the solid, so they're really trying to highlight the triangle. That's what you're supposed to be staring at. But these circles are kind of like in the background and they're going to tell you something. Okay. Let's see. Someone else said A and B are in the circle and C is outside the circle. Technically, where they place the letter, how they label it, they'll always label it wherever it's convenient. So this is like squishy squash, so they won't put it there. It makes sense to be here and not squishy squashed. I understand what you're saying. But technically, I'm gonna be technical. Can everybody see that this circle here? Is B and C on the circle or in the circle or outside the circle? Points B and C, is it on the circle, in the circle, or outside the circle? Yeah, so this is something that you have to get your brain used to. Ignore where C is, but look at the point. That point is on the circle. On the circle. So most of you said outside because of that's where the actual letter is. I'm not talking about the letter, I'm talking about the actual point where it represents. So that point is on the circle. Okay, and a circle is just made up of a bunch of points, a bunch of points that are a set distance away from the center. Very good. Someone else said the triangle is inside the two triangles. Very good. The triangle is inside the two triangles. I like that. Someone said the circles are interlocking with each other. Very good. We use the word intersecting. So they're intersecting each other. There's one more thing that I want you to know. Tell me everything that you know about a circle. I almost said the answer. Tell me everything you know about a circle. Tell me everything you know about a circle. Okay, besides, okay, very good, very good. We're getting it. Someone said it has no corners. Check. It has no angles. Correct. It's one whole circle and it's round. It's actually 360 degrees. Very good. Did you guys know that 360 degrees? Like if someone does a 360, right? It means they went all the way around what? A circle, right? They spun in a circle. It continues. Very good. Someone said it. Diameter. What is a diameter? What is the diameter? What is the diameter? Ooh, someone else said it. Yes. The diameter goes from, I'm going to try to do this right. The diameter goes from circle through the center to the circle. Like that. That's a diameter. Very good. Someone else said this word, radius. What's a radius? What's a radius? What's a radius? The radius is from center all the way out to the circle. So it almost looks like if I put a bunch of radii in here, it looks like a bunch of cuts in a pie. You guys all see this as pie? I do. What's your favorite pie? Don't get distracted. Just kidding. Very good. So we're actually going to talk about the radius. What do you know about the radii, meaning all the radiuses of a circle? What do you know about the radiuses of a circle? What do you know about the radiuses of a circle? So this radius and this radius and this radius, this radius. Yeah, they're all congruent. All the radii of this circle are congruent. Okay, that's an important thing that I want you to know. Okay, with that being said, because you know that all the radii are oh, I don't want all this, are congruent, what else do you know? Someone earlier said that triangle is an equilateral triangle. What does that word mean? Equilateral. Equilateral. Do you know how to break apart words? Have you done that before? Where you're like, oh, I didn't recognize this. It must mean this. Yeah. Equal is the first word you guys all saw. Very good. So what's equal? In this triangle, what's equal? All three sides are equal. Very good. If you've done any biology and you've done some of the dissecting, I'm not sure if you guys have done that yet, but if you work out, right? Does anybody know what these muscles are called? Like right under your armpit on the side of your body? Yeah, those are called your lats. Okay, short for lateral, right? So lateral literally means the side of something, right? So lateral means equal. Sorry, lateral means sides. So equal and sides. So these are all equal sides. Now, in geometry, you can't just say because it looks like it. But you're right. This is an equilateral triangle. But how do you know that? How do you know that? Let's start here. What's AB called? What's AB called? We just talked about it. No, not A, comma B, but like this segment, A, B. This path from A to B. What is that called? And I drew a bunch of them. I drew one right here. I drew one right here, right here. I drew a bunch of them. What did we call it? Yeah, it's the radius. What did we say about the radius? What did we say about the radii of a circle? Very good. They're always congruent. Okay, so now check this out. AB is the radius of which circle? The one on the left. We call them circle A. We always label circles by their center point. Circle A, is AB the radius of circle A or circle B? Which one is it the radius of? Circle A or circle B? Yeah, someone said it. Both. Okay, so you told me that the radii of a circle are congruent. So AB, I'm gonna focus on circle A. Okay, this guy here. This guy is congruent to this guy. Does everybody see why this is congruent to this? So whenever you have a circle, I'm gonna draw using this tool. Whenever I have a circle, right? And I have all these I guess I'll go with diameters. And I have all these diameters going across. I could do more. All of these radii are congruent. Does that make sense? All of them are congruent. So I'm going to mark them being congruent. This is how I mark something congruent. If I wanted to say this is congruent to this, I'd put a little tick mark so that everyone knows that this is congruent to this, but it's actually congruent to this, which is congruent to this, which is congruent to this. Does everybody see how to mark something congruent? So in the next couple slides, you'll see diagrams and there'll be like little marks on them. Does everybody now understand what those mean? Okay, what's the next part? Now you've proved that this is congruent to this because they're part of the same circle and the radii are congruent. How do I get this third side to be congruent to these two? How do I prove that that third side is congruent to the other two? Yeah, how do I prove CB is congruent to AB or AC? So I could do that, but I can't do it until you tell me how you prove that AB is congruent to CB. I can't just mark it congruent just because I want to. I have to prove that it's congruent. Does that make sense? How would you prove that? Now, I'm going to give you a hint. Focus on circle C. What do you notice about circle? Did I say C? I meant B. Circle B. What do you notice about circle B? Yes, very good. This is congruent to this. Very good. Why is this congruent to this based on what we just talked about? Because they're both what? They're both something. What are A, B, and B, C? What are they both? They're both what? What's that word? Yes, they're congruent because why? Why are both A, B, and B, C congruent? Because they're both, what's that word again? We used it here. Yeah, they're both radii. And we talked about in a circle, all radii are congruent. So that sounds like we need to add it to our little list up here. So let's see. Let's add this. In a circle, all radii are congruent to each other. I should draw a picture for this. I'll draw a picture later, guys. Okay, so does that make sense? Therefore, this is an equilateral triangle. Now look, it took us that long to get to where I wanted you to get to. This is the first problem that we've ever done. So it's going to feel like that, like, oh my gosh, Miss Johnson, this is taking so long. So the question that you're going to keep asking yourself is, what do I see? Now think about the very first things that you said about what you saw. You're like, I see circles, I see a triangle, I see points. And then someone said diameter, and I was like, yeah. And then someone else said equilateral triangle. I was like, how do we prove that? You can't just say that it is because it looks like it. All right, let's move on. So I'm going to give you a second to talk to your neighbor, and it's going to be this. It says, for example, we did this. We did this part because we did it. I wanted to do this together. My bad. Okay, so we're going to move on to this one. Why is this one called number 4? Wait. Oh no, you're good. Oh, by the way, what is the sequence of steps that led to this final diagram? What do you think? What was the first thing that they drew, do you think? What do you think they drew first? Which part of the triangle? Very good. Someone said triangle. Very good. But which part of the triangle? Be specific. Yeah, very good. Someone says AB. Very good. So first thing they drew was this one. And then they drew a circle with radius AB. And then they drew another circle with radius AB. And then they intersected them, right? And then they drew point C. And then they were able to draw triangle ABC. Very good. So if you said this two circles, you weren't wrong. It was just we needed this segment first. Okay. All right, let's move on. Okay, so very similar, very interesting looking diagram here. So I'm going to have you stare at this, and then I want you to write down a bunch of things that you can, okay? It's almost like, have you ever played that game? Oh, jeez. There's a bunch of games, but like categories or like Boggle or like something where you're trying to write down as many words or something as possible. So I want you to play this game with yourself, and I want you to look at this and give me everything that you notice about this. Even the things that you're like, Miss Johnson, this is so obvious. I don't need to say it. Say it. Okay. So it says, what can you say about triangles, quadrilaterals, or diagonals of the quadrilaterum that appear in the diagram? List several conjectures that you believe are true. So you're going to list as many things as you possibly can that you observe. And then they gave you a couple hints. What do you notice about triangles, quadrilaterals, or diagonals of a quadrilateral that appear in this diagram? Okay, so I'm going to give you a couple seconds to do that. Okay, so we switched over to my notebook. And okay, so here's our drawing. And it says, what can you... Sorry, I just want that bigger. What can you say about the triangles, the quadrilaterals? So what did you guys all get? Come on, give me some things that you noticed. I'm going to type. I'm going to put it, there we go. Oh, and some of you wrote stuff. Okay, here. So someone said, so there's two triangles, one facing up and one facing down. Pause right there. How many triangles do you guys see? All together, okay? I actually see more than 4. So your job is to find more than 4. Someone said 5. I actually see more than 5. Don't just keep counting up that. Like, actually look for them. When I say see, yeah, there's 8 of them. Very good. So in case you don't see them, so I'm just going to write that here. There are 8 triangles. Okay, so in case you don't see them, I see 4 small triangles. 1, 2, 3, 4. Okay, everyone see those 4? Okay, then I see the top triangle, ABC. Does everybody see that? And the bottom triangle, ABD. Does everybody see my 2 big top and bottom triangles? Yes? Where's the other 2 triangles? Yes, very good. CAD, and one of you used your fingers to draw it, and CDB. Very, very good. So for those of you who didn't see them, just get used to looking at triangles. And some of you are like, but Miss Johnson, like, are those really triangles? How would you say that? They're like triangles that are made up of other triangles. Very good. So what I said was, I see 8 different triangles, right? So yes, it is very good for you to be able to like, see all the triangles that I see. That's very, very good. Okay. So, based on what we learned last time, is there anything that you notice about these triangles? Yep, there's a point P in the middle. Very good. Oh, sorry. P is just the middle point. I forgot to look at your list of things that you guys said. I'm sorry. Okay, so someone said, yeah, there's like this almost like an X and Y axes right here, someone says. Very good. Anything congruent? Is there anything congruent? Yes, someone said they're reflections. Very good. So does everybody see the reflection of either CAB onto ADB or all the other reflections? You guys all see those? So very good. I'm going to type that out. So there's lots of reflections, right? Very good. And there's other pieces too. Is there anything congruent? Does anybody see anything congruent here? Very good. Someone said it. Miss Johnson, the radius thing that you keep telling us. Very good. So AC, AB, AD, DB, BA, and CB are all congruent. So I can go like this. Did everybody see that? Now, you learned a long time ago how to tell if triangles were unique. And it's okay if you don't remember, but we're gonna do lots of reminding about how triangles are gonna be congruent and stuff like that. But I'm gonna remind you that because all three sides, CAB is congruent to itself, ACB is congruent to ADB. Does everybody see how those two triangles are congruent? That has to do with the reflection that someone said. Similarly, those other triangles are congruent, right? So very, very good. So I want to introduce you to given. Given is something that you're going to see over and over again in these next couple units. Given means they gave you something. I know that sounds very interesting, but they told you that these two are circles. And when they say circle A is congruent to circle B, they're saying circle A is congruent to circle B, meaning their radii are congruent. Remember that circles are labeled by their centers. Okay. There's actually a lot more observations. Like, for example, all four of these small triangles are right triangles, meaning they're perpendicular. And that has to do with the fact that all four of these triangles are congruent. It also has to do with the fact that the left triangle is congruent to the right triangle. Do you remember this word isosceles? Do you remember this word isosceles? All right, let's add that to our next thing here. So we have to talk about equilateral too. Equilateral triangle means, what does it mean again? Yeah, this means equal sides. It literally means equal sides. What is isosceles? What do you think isosceles means? So isosceles means, and then there's some arguing about this in the math world. So I'm just going to write it like this: at least two sides are congruent. So technically, we don't say sides are equal. We really actually say congruence. Have you guys heard of this word congruent before? Have we heard of this word, the congruent? I'm going to define it for you guys. This is going to kind of be like our glossary, if you want. I just say same size, same shape. Okay. All right. So I wanted to continue because we're going to go on forever here. So we could also call these triangles isosceles, equilateral. We could call this shape here shape ADBC. What is that called? Shape ADBC. What is that called? And that's how you just name it. You just name it by its letters. Anybody know what that's called? ADCB? ADBC? So we don't call it a diamond. Technically, a diamond is a 3D figure, right? It's what some people have on their rings. We call it starts with a R. Do you remember this? H. No. Rhombus. Do you guys remember rhombus? Okay, so let's go define what rhombus is because we're going to have to make sure that we understand this. Rhombus, this is from old stuff. Rhombus is a four-sided shape where all sides are congruent. Okay. All right. So it has four sides that are congruent. There's more, and I'm not going to go over all of them, but there's just a bunch more. The practice today is, do you see what we see? Okay. Here are some possible conjectures that you might have that you made as you thought about the construction of the previous given diagram. Select one of the statements and write a paragraph that would convince your partner that the statement is true. Your partner should work on another statement. Then work together to revise your proofs. Okay, so here I'm going to pause. We're going to work on these two. So we're going to continue on, and we're actually going to prove stuff. Did anybody want me to do one of these, both of these, none of these? A completely different one. Doesn't matter, Miss Johnson. Oh, where'd my chat go? There it is. Oh, both. Okay. So I'm just going to talk. I'm going to walk you through them. I'm not going to write a paragraph about them because we're not at that stage. I just want you to hear what you should be hearing. So proving that CAD and CBD are congruent isosceles triangles. So CAD and CBD are congruent isosceles triangles. Okay. So I need to write down for you all the different ways that you can prove triangles are congruent, but one of my favorite ways is SSS, which stands for this side is congruent to this side. I'll actually highlight it so it makes sense. So this side is congruent to this side, right? This side is congruent to this side. And then this side is, oops, other color, my bad. This side is congruent to itself. Does that make sense? Okay. So what that means is we have two triangles whose side are congruent. Does that make sense? Therefore, I proved that these two triangles are congruent. Do you have to write a paragraph? Eventually, yes, but right now, no. So if I had to write my statements down, I'd go something like this. I can't do it. I have to actually write it down. Sorry, I'm going to just write this down really quick. So I would say something like AC, ignore the notation for now because I have to teach you notation, but I don't want to do it wrong, is congruent to BC and AD are congruent to BD. And this is because radii of congruent triangles, circles, are congruent. So this is Miss Johnson's shorthand. This is not math handwriting. I'm just saying that radii of congruent circles, they gave you that they're congruent circles. They're congruent. That's what we talked about last time, right? Okay, so we have side, side, and then we need this third side. So that third side is going to look like this. So CD is congruent to itself. So for those of you who are paying attention to details, you keep noticing that I keep putting this little hat on all these segments. And the reason why I need hats on all these segments is because I'm talking about the segment, not how big it is. Okay. So why is CD congruent to itself? Anybody know why CD is congruent to itself? It's like an obvious statement. You guys are like, yeah, because it's congruent to itself. So what we call that in math is it's called the reflexive property. What does reflexive property mean, Miss Johnson? It means when I look in the mirror and I see myself, I'm like, yo, that's me. And then when I see my I don't know, I'm pretending. When my reflection sees me, it's like, yo, that's me. Does that make sense? So if I looked in the mirror and I didn't see me, I saw something else, like a stuffed animal or something else, I'd be like shocked, right? Okay, so this is the reflexive property because it looks like itself, right? And then finally, we can just say that triangles, what triangle? Oh, CAD is congruent to triangle CBD because of the SSS. SSS we'll talk about later, but for now, that's good enough. So I'm not used to writing in paragraph proofs. I had to learn how to do those in college. Some people are more comfortable in writing in proofs. Can you imagine me writing this as a paragraph? Okay. This is almost called like a 2-column proof, where on one side we have our statements, and on the other side we have our justifications or our reasons. Okay. For B being a quadrilateral, ACBD is a rhombus. We kind of already proved it. So the definition of a rhombus is all 4 sides are congruent. So my beginning would look exactly the same, except for I'd make this congruent to this, congruent to this, congruent to this. It'd be one long statement. Like I would just literally take this guy right here and move him right here and put this is congruent to this, is congruent to this, is congruent to this, right? So there goes that, right? So now that they're all congruent, I'm done. I'm done proving that the rhombus, that it's a rhombus, because definition of rhombus says that it's all 4 sides are congruent. Very good. Thanks for listening.